Hello, in this video I will show how the Raspberry Pi will be sending data to the dspic33. This is an overall system block diagram for the final product. In this demo I'll be explaining the highlighted area that will be the data communication between the Raspberry Pi and the microcontroller. So the Raspberry Pi will be sending data to the microcontroller based on the digital user input to the LCD touchscreen. So the user will select different values, will select different buttons on the LCD touchscreen, and based on that, the Raspberry Pi will send different data packets to the microcontroller. This diagram over here explains the data communication with the Raspberry Pi. As you can see here on the left side, we have the touch screen. The user will have access to this part, and then we have the Raspberry Pi, the dspic33 over here, and at the right side you have the motor. The user will select different values, different buttons. So as you can see here, we have end button, we have start button, we have pause button, we have workout type, or that will select whether we have a dyno mode or exercise mode. So we have two workout types, and also the user can change the resistance value from 0 up to 100. The wheelchair size, that will be the wheelchair diameter. Can go up from 22 up to 26, and then the user also can select the workout duration. So based on those flags, when the user select different buttons, several flags will be raised to the Raspberry Pi, and then the Raspberry Pi will send data packets over here, as you can see, to the dspic33. Now, the packet that will be sent is over here. This whole packet will be sent as a string. We have different characters over here. I will explain later what each one is responsible for, but I'll give you a brief description what the Raspberry Pi will be sending to the dspic33. So as you can see here, the Raspberry Pi will tell the dspic33 whether to start or stop receiving data. It will send the dspic the resistance value, the wheelchair diameter, and the workout type. And then after that, after the dspic receives that packet, it will process it and then send it to the motor. Now, the packet I was just talking about, this packet will be sent to the dspic33 every time the start button, end button, pause button are pressed, or whenever the user will select a different resistance value or wheelchair size. Also, the exercise type, that's going to be either dyno or exercise mode. This is the packet over here, that's the global message format. The first character, as you can see here, is a $sign. This is just a receive character. This character is used to indicate that a new data package has been received. And then you can see here the second character will be either 0 or 1. If it's 0, it means the dspic should stop receiving data. And when it's 1, it means the device is active. That means the user selected the start button. And then you have the second character, that's the resistance value. The user will select different resistance value and it will be updated on this character. And then you have the wheelchair size, the wheelchair diameter. This will be also updated depending on what the user selects before the workout starts. You cannot change this character during the workout. It can only be changed before pressing on start button before you start the actual workout. And then we have the exercise type. This is going to be either exercise mode or dyno mode. And then lastly we have the bound key character. This is just a terminating character that is used to indicate that the data package has been completed, so the dspic can start receiving a new packet. So as I mentioned earlier, the Raspberry Pi will be sending data to the dspic33. So in general, the Raspberry Pi will be sending data to dspic33 via UART cable. So what are those data being used for? So the data is going to be used for notifying the dspic33 whether to start receiving data or stop receiving data. That also the Raspberry Pi will send each of the resistance value, wheelchair diameter, and the workout type. This is the only data that the Raspberry Pi will be sending to the dspic33. Over here, this is just an explanation on what we'll see later on in this demo. As I said, the Raspberry Pi will notify the dspic when to start receiving data. And as you can see here, the character that's responsible for that purpose is number 1. This is going to be number 1 and it will be sent as a character. And then 0 means the device, it means the user select either stop button or pause button. Then we have the workout type, as you can see here at the end of the packet. When we have 0, it means the user selected exercise mode. When it's number 1, it means the user selected dyno mode. And then lastly, you can see here this character represents the resistance value. This will change from 1% up to 100%. And then we have the wheelchair diameter. This will range from 20 up to 26, and this character over here will be changed based on what the user selects. And then we have the workout type over here, as I mentioned earlier over here. Okay, so now we'll talk about the connection between the Raspberry Pi and the dspic. The communication in this section is done through a UART serial connection. A RS-232 cable was used to connect between the dspic33 and the Raspberry Pi, as we can see here in this figure. On the Raspberry Pi end, the RS-232 cable will be connected to the USB port, and then on the dspic33 end, the RS-232 cable will be connected straight to the UART pins. Over here we have a connection between Arduino Uno and a Raspberry Pi 3. This diagram represents a connection. that was done in order for us to test if the data packets are being sent to the dspic33 correctly. But instead of using the dspic33, I used Arduino Uno. Now, just to keep in mind that the Raspberry Pi software will not change whether we are using Arduino or dspic33. So this microcontroller over here, the Arduino, was only used to track the data packets that the Raspberry Pi 3 sends to the dspic33. So we are just making sure that the Raspberry Pi is sending the correct data packets. So the schematics over here explain the system that was created in order to test the data packets that the Raspberry Pi will send to the dspic33. As I mentioned earlier, in order to test everything out, I use an Arduino Uno. This over here explains the connection, and over here between the Raspberry Pi and the Arduino we have the RS-232 cable, and then between the Arduino and the serial monitor we have a USB cable that will go into USB ports on both ends. Over here, as you can see here, that's the Arduino and that's the RS-232 cable. That's how the connection was done, and then over here the part is not shown. This part will be connected to the USB port on the Raspberry Pi. Now I'm going to show you the serial monitor that I'll be using. Right now over here, that's an Arduino serial monitor on the PC. What I'm going to do now is open the Raspberry Pi and open the GUI screen, and then I will select several buttons on the GUI screen, and then we'll see what data packets will be sent to the Arduino. So that data packets will be the same data packets that will be sent later on to the dspic33. So for the final product, that data packet will not change. The software will not change. Alright, now I open the GUI screen. Now I will select our workout type to be exercise mode. I will select the wheelchair diameter to be 22 inches. I will select the resistance value to be, let's say, 6%. Then I'll put the workout duration to 7 minutes. Now I'll press on start, and then you will notice packets appearing on the serial monitor. Now I press on start. So now we can see here the first character is 1. It means the device is active. Now I'll press on pause, and you'll notice that character will change into 0. You can see here, now it's changed into 0. It means the device is paused. Now I will press on start again to resume the workout. Now you notice the character has changed into 1. Now I will change the resistance value to 9. You see here, now we have 9. I will change more. I put it now on 10, on 11, I'm sorry. You can see over here, we have 11. Now I will end the workout. You can see here, now we have over here, this character means the device is stopped. Now I will start a new workout. I will select our workout type to be as dyno mode. and I will select the wheelchair size to be 24 inches, and then I will press on start. Now you can see here the device is active, and then we have the resistance is set to 11, and then we have the wheelchair size is 24. Now I will pause the system. You can see it's changed to 0. Let me clear the output so we can see. Now I will press on resume. You can see here the first character is changed to 1. Now, just to point out, in the dyno mode, the resistance value will increase from 1% to 100% in 20 seconds. The dspic33 will be responsible for that part. The Raspberry Pi will not be responsible for changing the resistance value. Hopefully that video explains how the Raspberry Pi will be sending data packets to the dspic33, and hopefully I will send another video later on to explain how the Raspberry Pi will be, how the dspic33 will be sending data packets to the Raspberry Pi. Thank you for watching that video.